Hello and welcome back to the channel. Today we're examining one of the most intricate drone operations in modern warfare history. This is the story of how a coordinated strike involving 8 unmanned aerial vehicles challenged conventional air defense systems and highlighted vulnerabilities in critical infrastructure protection. In the early morning hours of a winter day, silence was broken by a series of explosions at a major nuclear facility. Within approximately 120 seconds, a swarm of Ukrainian An-196 Lyuty long-range drones had executed a precision strike against the Smolensk nuclear power plant, targeting a $7.8 billion strategic asset. This attack came as a calculated response to previous strikes on Ukrainian energy infrastructure, representing an escalation in the ongoing conflict's targeting of power generation facilities. The operation demonstrated how modern unmanned systems could be employed against heavily defended installations, forcing military analysts worldwide to reconsider assumptions about air defense effectiveness. The strike was anything but simple. It required meticulous planning, sophisticated technology, and human intelligence gathering on the ground. 8 drones participated in the mission, with 2 designated as decoys and 6 carrying offensive payloads. But the aerial component was only part of the equation. A small team of partisans operated deep within Russian territory, positioned near the Desna forest region, providing real-time intelligence that would prove critical to the mission's success. These ground operatives fed continuous data streams about the locations and movements of mobile air defense units, allowing the drone operators to anticipate defensive responses and adjust their approach accordingly. The An-196 Lyuty drone itself represents a fascinating example of wartime technological adaptation. It's a domestically produced, unmanned aerial vehicle that incorporates advanced artificial intelligence developed in the United States for navigation purposes. Perhaps most importantly, it relies on Starlink satellite communication systems, which provide a jam-resistant link between operators and aircraft. This combination gives the platform the capability to conduct strikes deep inside hostile territory with a level of precision that would have been impossible just a few years ago. Each drone can carry substantial payloads over distances of several hundred miles, operating at altitudes that make detection and interception challenging for traditional air defense systems. The choice of target was deliberate and strategic, rather than attempting to strike the nuclear reactor itself, which would have been extremely difficult and carried enormous international consequences. The planners identified a critical vulnerability: the 500-foot-tall cooling tower serving the facility's 3rd power unit. This structure represents a fatal design flaw, inherited from the Soviet era. Unlike modern Western nuclear installations, which feature reinforced containment domes protecting all critical components, this cooling tower stood completely exposed to the elements and potential attack. While the facility was protected by Russia's advanced S-400 air defense system, a sophisticated platform valued at over $1 billion, the entire Ukrainian operation was designed specifically to exploit that system's weaknesses and blind spots. The Russians considered their harsh winter weather a natural defensive advantage, making flight operations more difficult and providing cover against surveillance. What they failed to anticipate was that Ukraine had developed tactics to turn that same weather into a weapon against the very systems designed to protect high-value targets. Snow, cold, and low visibility could work both ways. The mission began at 1:09 in the morning. From a concealed airbase near Chernihiv, 8 An-196 Lyuty drones lifted off into the darkness. They climbed briefly before leveling off at an extremely low altitude of just 100 feet above the terrain. At this height, they were flying below the radar horizon, using the simple physics of Earth's curvature as a primary defensive measure. Ground-based radar systems struggle to detect low-flying objects at long ranges, because radio waves travel in straight lines while the planet's surface curves away. This creates a natural blind zone that skilled operators can exploit. Each unmanned vehicle carried a 165-pound incendiary warhead, designed to burn at temperatures exceeding 2,000 degrees Fahrenheit upon detonation. These weren't simple explosive devices meant to create blast damage. They were specifically engineered to generate intense heat that could compromise structural integrity and destroy mechanical systems through thermal stress. The drones operated as what military analysts call a dynamic swarm, guided by artificial intelligence that processed vast amounts of data in real time. Their communication link to operators ran through an unjammable Starlink satellite connection, making traditional electronic warfare countermeasures far less effective than they would be against conventional radio-controlled aircraft. However, their most valuable data stream originated not from satellites, but from human intelligence sources on the ground. 3 partisan operatives hidden in the Desna forest were transmitting the precise, real-time locations of Russia's mobile Pantsir air defense units, which represented the last layer of protection for the Smolensk facility. These short-range systems are designed specifically to intercept low-flying threats like cruise missiles and drones, making them a critical obstacle that had to be tracked and avoided. Without current intelligence on their positions, the entire mission could fail before reaching the target area. But even the most sophisticated, technology must contend with nature. As the swarm proceeded toward its objective, a brutal 20-mile-per-hour crosswind began pushing the entire formation off course. The deviation appeared minimal at first, just 3.6 degrees, but over a journey of 368 miles, such an error would be catastrophic. The drones would miss their target by miles, and the carefully choreographed attack would accomplish nothing. For any conventional navigation system, this might have spelled mission failure. But the Lyuti's onboard artificial intelligence wasn't a simple autopilot following a predetermined path. It was a sophisticated decision-making system capable of processing thousands of variables simultaneously and making continuous micro-adjustments to compensate for changing conditions. It recalculated trajectories, adjusted control surfaces, and kept the entire swarm locked on a precise heading toward the target despite the atmospheric interference. Back in a control center in Kiev, operators monitored telemetry streams, watching data pour in from each aircraft. The system was performing flawlessly, exactly as expected. Then, with just 50 miles remaining to the target zone, disaster struck. A single icon on the operator's display screen flashed from green to red, and the data feed from Drone 7, one of the 6 primary attack aircraft, suddenly vanished. The unmanned vehicle was still flying, but it had lost its satellite connection and was now operating completely autonomously. 72 seconds from the target zone, and one of the critical strike platforms was essentially blind, unable to receive updated instructions or course corrections. As the swarm crossed the 50-mile threshold, the entire electronic environment changed dramatically. The S-400 air defense system's powerful 92 N6E radar, known by the NATO designation Gravestone, detected the incoming threats and locked on. This is an extraordinarily capable system, powerful enough to simultaneously track 300 separate targets across enormous volumes of airspace. Inside the Russian command post, computers process the threat data with mechanical efficiency, assigning target priorities, calculating optimal intercept solutions, and presenting operators with firing recommendations. The human defenders had only seconds to make decisions. The response came immediately. A 40 N6 missile roared into the night sky, its rocket motor leaving a brilliant white contrail against the darkness. Moments later, operators watched on their displays as the missile's icon merged with one of the drone contacts, and a silent expanding fireball marked a successful interception. The first unmanned aircraft was destroyed, eliminated with textbook precision. Inside the command post, there was a brief moment of relief, a sense that the defensive systems were working exactly as designed. But that kill was entirely expected. The destroyed aircraft was Decoy 1, and its loss was planned for. As fragments of the destroyed drone tumbled toward the ground, the remaining 7 aircraft executed their programmed response. They didn't scatter or retreat. Instead, they began a series of erratic, zigzagging maneuvers, constantly changing altitude and direction, while using the heavy falling snow as a 3-dimensional curtain to mask their movements. This is where the limitations of even the most advanced air defense systems become apparent. The S-400 was engineered to track and destroy fast-moving, high-altitude targets like fighter jets and ballistic missiles. It excels at that mission. But a swarm of slow-moving, relatively small targets weaving through a snowstorm at low altitude presents an entirely different challenge, one the system wasn't optimized to handle. The targeting displays for the remaining drones began to flicker erratically on operator screens. The system was struggling to maintain consistent locks on targets that kept appearing, disappearing, and reappearing in unpredictable patterns. Meanwhile, on the ground in a watchtower overlooking the facility, a Russian guard lit a cigarette to ward off the bitter cold. He stared out into the darkness, seeing nothing but falling snow, completely unaware that 7 silent machines were now maneuvering just beyond his line of sight, closing in on the installation's most vulnerable point. The S-400 system should have been able to handle this threat easily. After all, it can track objects as small as a baseball at extreme ranges in space. So why was it struggling to maintain locks on 550-pound unmanned aircraft? The answer lay in a Ukrainian pioneered tactic that military analysts are now calling snowjamming. The drones were broadcasting low-frequency electromagnetic interference, not directly at the radar system itself, but into the surrounding snowfall. Heavy, wet snowflakes acted as millions of tiny reflectors, scattering the radar energy into chaotic, unreadable patterns. It's the electronic warfare equivalent of throwing sand in an opponent's eyes. You don't block their vision entirely. You overload it with so much useless information that they can't distinguish genuine targets from background noise. Frustrated and increasingly desperate, the Russian commanders deployed their own electronic sledgehammer, the Krasuka-4 jamming system. From 186 miles away, this powerful platform began pumping out a massive wave of electromagnetic energy, a brute force attack designed to sever radio control links and cause any drone in the region to fall from the sky. Against conventional unmanned aircraft operating on standard radio frequencies, this approach would be devastatingly effective. Operators would lose contact with their platforms immediately, and the aircraft would either crash or activate fail-safe protocols and return to base. But the Krasuka's immense power was completely ineffective against the Lyuty platforms. The system was jamming frequencies that the drones weren't even using. They weren't listening to radio commands transmitted from ground stations. Their primary communication ran through the Starlink satellite network on entirely different frequency bands with sophisticated encryption and anti-jamming protocols. It was like trying to disrupt a phone conversation by shouting at a television. You're transmitting a signal, but in a form the target system isn't designed to receive. At precisely this moment, the partisans on the ground played their final card. They detonated a small, improvised explosive device, not targeting personnel or vehicles, but positioned at a secondary radar installation. The physical explosion immediately severed power connections to that station, creating a gap in the defensive radar coverage. In the chaos and confusion created by the blast, they activated a ground-based navigation beacon, transmitting a pinpoint-accurate position reference directly to the incoming swarm. The drone's artificial intelligence systems no longer needed GPS coordinates, which could be jammed or spoofed. They now had what pilots call a lighthouse, a fixed reference point guiding them directly to their destination. On paper, according to technical specifications and manufacturer claims, the S-400 system should have achieved approximately an 80% kill rate against this type of threat. But warfare isn't conducted in laboratories under controlled conditions. This was a real-world engagement where Ukraine had successfully transformed Russia's perceived advantages into critical weaknesses. The vast winter landscape and proximity to a porous border had been turned from defensive assets into vulnerabilities that enabled both the drone approach and partisan operations. The decoy's destruction had served its tactical purpose, but it created an unexpected complication. Wind caught the thick, oily smoke from the burning wreckage and blew it directly across the path of the main swarm. The drone's optical sensors were suddenly blinded by the dark haze, triggering automatic safety protocols that initiated immediate course corrections. Two of the aircraft veered off their planned trajectory, their navigation systems temporarily confused by the loss of visual reference points. In that moment of chaos, the Russian commander made one final desperate attempt to regain control of the situation. He ordered a full-power, sector-wide barrage from the Krasuka 4 system. For 30 agonizing seconds, every display screen in the Kyiv control room went completely blank. The Starlink connection, video feeds from the drones, telemetry data showing speed, altitude, and heading, all of it was drowned in an overwhelming sea of electromagnetic interference. The unmanned aircraft were entirely on their own, cut off from human oversight and operating autonomously in hostile airspace, with seconds remaining until they reached the Baos target. But this scenario, complete communications loss in a contested environment, was precisely what the system had been designed for. This is where the American-developed artificial intelligence took complete command. It wasn't simply following a pre-programmed route stored in memory. It was actively analyzing the environment and making independent decisions in real time. Military technologists sometimes compare it to the difference between a basic GPS navigation unit that follows a predetermined map and a fully autonomous self-driving vehicle that can respond to unexpected obstacles and changing conditions. The AI immediately recognized that GPS data was no longer reliable and disregarded those inputs entirely. It locked onto the partisan's ground beacon and replotted the entire attack approach for all remaining aircraft in less than 1 second. When the communications link restored in Kyiv, operators saw their screens light up again just in time to witness the final Russian defensive response. Realizing that his electronic warfare assets had failed to stop the attack, the commander had released his most dangerous weapons. 2 Su-35 fighter aircraft, among the most capable air superiority platforms in the Russian inventory, were now screaming toward the target area at Mach 2, approaching twice the speed of sound. This should have ended the mission immediately. A multi-million-dollar fighter jet, equipped with advanced radar, infrared sensors, and air-to-air missiles, facing off against a slow-moving drone, isn't a fair fight by any measure. But the unmanned aircraft had one final trick programmed into their defensive protocols. They dropped altitude rapidly, diving into a 20-foot deep channel of the Desna River. The riverbanks on either side provided natural shielding, creating a radar blind spot that the Su-35's powerful look-down radar systems couldn't penetrate effectively. The fighters roared overhead, their pilots searching frantically for targets that had seemingly vanished from their displays. In the Smolensk command bunker, the facility's military commander stared at a tactical display that provided no useful information. His billion-dollar air defense shield had failed to stop the attack. His powerful electronic warfare systems had been ineffective. And now, somewhere in the blizzard surrounding his installation, ghost signals indicated that multiple threats were still approaching his most valuable and vulnerable asset. He had no idea exactly where they were or when they would strike. At precisely 04:16 and 47 seconds, the 4 remaining drones burst from the cover of the Desna River Valley and began their final terminal attack approach, 43 seconds to impact. Through the lead aircraft's forward camera, operators in Kyiv could see the target filling their screen: the Smolensk cooling tower, a 500-foot monument to outdated Soviet design philosophy. The high-resolution, Imagery revealed cracks in the aging concrete, exposed reinforcement bars where weather had eroded protective covering, and most importantly, the fatal architectural flaw that international inspectors had warned about for years. This critical component of the nuclear facility had no reinforced containment structure, no hardened dome to protect it from attack or accident. It was essentially a giant, fragile concrete shell standing fully exposed. On the ground, one final Pantsir air defense crew, their primary radar still showing phantom returns and unreliable data, made a desperate decision. Ignoring the electronic displays entirely, they switched to pure optical sights, using their eyes and manual tracking to acquire a target. They achieved a lock and fired. The missile tore through the snow-filled air and found its mark. Drone 6 vanished in a violent explosion that shook the other aircraft, but it was too little and far too late. The 3 remaining attack platforms didn't hesitate or divert. They simply adjusted their formation spacing slightly and accelerated toward the target. In Kiev, the operator sat frozen, barely breathing, his heart pounding. Below his aircraft, chaos reigned across the facility. The S-400 system was still reporting phantom threats miles away from the actual attack vector. Russian soldiers ran in confusion between buildings, unsure if the threat was real or another electronic deception. The final countdown began. 12 seconds remaining. The drones made minute adjustments to their angle of attack, using gravity and velocity to maximize impact force. 8 seconds. The massive concrete tower filled every pixel of the video feeds. 3 seconds. The operator could see individual cracks in the deteriorating walls rushing up to meet the cameras. At exactly 04:1700 hours, the 3 remaining AN-196 Leyuti drones executed their terminal dives with mechanical precision. Their integrated GPS guidance systems locked onto the precise World Geodetic System 1984 coordinates and made final micro-adjustments. This wasn't a crude area bombardment attack relying on explosive force alone. It was industrial-scale precision targeting, more akin to surgery than conventional warfare. The first 165-pound incendiary warhead slammed into the cooling tower's concrete wall precisely 3 feet from the central axis of the main water ventilation shaft. 2 more impacts followed within milliseconds, striking different structural points along the same trajectory. But the true sophistication of the mission became apparent in the next fraction of a second. The fuse on each warhead had been set with a 0.8-second delay. This critical timing detail ensured that the warheads didn't simply detonate on the tower's outer surface. They punched through the 2-foot-thick concrete wall and detonated inside the structure itself. The result was a devastating physics lesson. The blast wave, with an overpressure exceeding 10 pounds per square inch, was trapped within the tower's interior. With nowhere to escape, it slammed against the concrete walls, rebounding on itself and amplifying its destructive force with each reflection. The 500-foot tower had effectively been turned into a giant sealed pressure vessel, containing and magnifying the explosive energy. The primary water pipes that served as the cooling system's arteries weren't merely ruptured or damaged. They were vaporized, instantly transforming from solid metal infrastructure into superheated gas. Deprived of its cooling liquid, the massive turbine serving Unit 3 began to fail catastrophically. Internal temperatures spiked to 120 degrees Fahrenheit in just 43 seconds, far exceeding safe operating parameters. The good news, at least from a global safety perspective, was that the reactor's automated safety systems functioned exactly as designed. They initiated an emergency cold shutdown protocol that successfully prevented any radioactive material release into the environment. The bad news for Russia was that the entire facility went dark, immediately cutting power to 500,000 homes and multiple military installations across the region. The preliminary damage assessment reached a staggering $150 million, and 1 gigawatt of generating capacity had vanished from the Russian electrical grid in a matter of seconds. On the ground, chaos engulfed the facility. Soldiers and plant workers ran between buildings as fire sirens wailed into the blizzard, their sound echoing off the twisted steel and shattered concrete of the collapsing tower. Thousands of miles overhead, a passing American intelligence satellite captured the entire sequence of events in 14 high-resolution photographic frames. The first image showed an intact cooling tower standing against the winter landscape. The final frame showed a gaping, steaming hole where the structure's core had existed moments before. Russia had deployed a billion-dollar air defense system to protect a multi-billion-dollar strategic asset. Ukraine had circumvented it using $150,000 worth of unmanned aircraft and a brutal lesson in applied physics. The true impact of the strike couldn't be measured simply in twisted metal, destroyed infrastructure, or the initial $150 million repair estimate. The real damage was strategic, creating a cascade of military, economic, and political consequences that rippled far beyond the immediate target. The most immediate military effect was catastrophic. With its primary power source severed, the S-400 air defense system protecting the western border region went completely offline for 72 critical hours. The billion-dollar defensive network that was supposed to create an impenetrable shield had been reduced to an inert collection of expensive but useless hardware. This wasn't merely a tactical inconvenience, it was an open invitation to further operations. While Russian forces scrambled to restore power and defensive capabilities, Ukraine seized the initiative and increased operational pressure simultaneously across 8 different sectors of the front. The dynamic had fundamentally shifted. The side that had been defending against relentless attacks was now dictating the tempo and location of engagements, forcing their opponent to react rather than act. The damage quickly spread beyond purely military considerations. The Smolensk facility had been a major supplier of electrical power for export, and with 1 gigawatt of its output eliminated, the Kremlin faced impossible choices. Russian officials were forced to cut electricity supplies to Belarus, a critical ally, by 20%. This wasn't simply a broken commercial contract or a minor diplomatic inconvenience. It was a political humiliation that strained one of Moscow's most important relationships. It was also a financial disaster, costing the Russian government an estimated $50 million per day in lost export revenue. This was economic warfare conducted with drones, bleeding the Russian treasury and creating domestic political pressure. This cascade of military, economic, and political failures reportedly landed on one desk in particular. In an emergency meeting inside the Kremlin, according to sources familiar with the discussion, a furious Vladimir Putin demanded answers to a single humiliating question. How did 8 drones and 3 operatives in a forest accomplish this against us? That question cuts to the heart of what this operation revealed about modern warfare. Russia had protected a multi-billion-dollar nuclear facility with a billion-dollar air defense system, supported by sophisticated electronic warfare capabilities and fighter aircraft. On paper, the defensive advantages were overwhelming. Ukraine had deployed 8 unmanned aircraft, a small group of partisan operatives, and a deep understanding of their adversaries' weaknesses and overconfidence. They recognized that the S-400, despite its impressive technical specifications, was fundamentally a brute force instrument designed to destroy bombers and missiles, not to counter a distributed, intelligent swarm. They understood that a system completely dependent on centralized infrastructure and power grids carried inherent vulnerabilities. Most importantly, they recognized that Russia's greatest perceived advantage, the brutal and unforgiving Russian winter, could be transformed into a weapon to use against them. In the final analysis, this engagement wasn't won by the side with the most expensive equipment or the most powerful weapons. Victory went to the side that was creative enough to turn falling snow into an electronic warfare asset, and patient enough to position human intelligence sources exactly where they would be needed. It was a triumph of ingenuity over raw force, and a demonstration of the new realities shaping 21st century conflict. Success belongs not to those who possess the largest missiles or the most numerous tanks, but to those who can develop and implement the most disruptive strategies. Thank you for watching. If you found this analysis valuable, please like and subscribe, and make sure to hit the notification bell so you don't miss our upcoming examination of how partisan operatives use thermal signatures to deceive Russia's most advanced sensor systems.